Here we'll look at techniques to display 3D data. So this is where we have functions of two variables, be it temperature in a plane or the height of something compared to its x and y coordinates, or any other function that takes two input variables. We'll call it x and y. So one way we can display these are using a mesh plot, but most of the 3D plots are going to behave similarly, but display our graphics in a slightly different manner. So where we need to start with, for kind of the simplest way to use a mesh plot, is we have to have x locations and y locations for where we know our dependent variable, I'll call z, or in this case I'll just work with, say, temperature. Right, so let's say that we have a rectangular plate and we're measuring the temperature at specific x locations and y locations. So for example, I'm measuring the temperature at 0 meters, 1 meter, 2, 3, 4 meters across the plate. And I'm also going to measure the temperature at y coordinates, 0, 2, 4, I'll just do it at 3 to keep it a little bit simpler here. Alright, so at 5 x locations, 3 y locations, but I'm actually going to be measuring the temperature then at 15 places, because it's every combination of x and y I'm measuring my temperature. So if I have this temperature matrix, it has to have the same number of columns as x does elements and the same number of rows as y has elements, which is a little bit confusing here because generally we would think rows are associated with x, columns with y, but for this the opposite is true. So the same number of columns as entries in x and the same number of rows as entries in y. So for example, this first row means that these are going to be the temperatures at when all the y values are 0, and then the corresponding x locations. So if I take the temperature here, maybe I have 25, 25, I'm measuring 30, and then 28 and 25. Now these are the temperatures I have when y is 2, and then the corresponding values of x. So here the temperature might go up a little bit. And for this example, I'm just making up numbers. We're going to see how it displays them. And now my last row is my measurements when y is equal to 4, and then again the corresponding values of x. Alright, so I have 15 temperature entries corresponding to every x and y combination. So I'm going to first use the mesh plot. Again, there are different ways to use mesh plot. In this instance, I'm going to give it a vector value for x, a vector value for y, and then my matrix T as my different arguments. And if we run this, we get this 3D display of our data that we can rotate. And it's going to help especially here if I give labels so I know which is my x-axis and which is my y-axis. So again, I run this, and I can rotate around. I can see it from different viewpoints here. So here, again, the way it's displaying our vertical axis, that's the temperature in this example of the plate at these different locations. So we see how it corresponds here to the values of x and y. So again, where y is equal to 0, I see that x, I have different temperatures for the different values of x, and that corresponds to, again, that first top row here I had for t. A different way to display the data, instead of using the mesh command, there's a similar graphic called surf for surface. So if I run this, it looks kind of like the mesh command, but we see that the squares now have different colors corresponding to different z values. And if we use this color bar command, that's going to add the color bar to my graphics display. So the color corresponds to the value of z, or in this case the temperature, at these various spots. So in this case we can also change the type of colors it's using a color map. So a nice one, especially to display temperature, is if we use color map jet. And if I run this, now we see that the color scheme it's using has changed. So now for lower temperatures it's using a cooler blue color, and for warmer temperatures it's using this hotter red temperature or red color to display that. And if we look in the documentation for color map, there's different built-in color maps that are good for different purposes for showing different amounts, different types of contrast. So if we see some of the color maps that are available here. Here we have the different options that are built into MATLAB. So here was the jet that goes from smaller values being blue, larger values being kind of this dark red. And then this whole array of choices we have here for the different types of color schemes that we are able to use. So we have winter. We have winter is the default color in this version of MATLAB. For other versions of MATLAB, jet is the default color. We have cool, HSV, and all these different, and we can make our own. If we want a black and white one or a grayscale one, we can use this bone. So we see here that higher values are white and lower values are going to be black, and then in between is kind of this grayscale. But that's the basic way that we use these 3D tools. Is one way we can do it is give it an X vector, a Y vector, and then a matrix of these corresponding Z values that it's going to plot.